A continuous time signal can be represented in its samples and can be recovered back when sampling frequency of S is greater than or equal to twice the highest frequency of that component, and this is expressed as f of S is greater than or equal to 2fm. So let us consider a signal for proof in this statement. Consider the signal x of t. So the spectrum of x of t is band limited to the frequency fm. So now we are multiplying this x of t with the impulse train dou of t with the period t. So the output of the multiplier is a discrete signal and it is called sampled signal, which is represented by y of t. The following diagram will show the diagram shows the sampling of the signal x of t. Here it is observed that the sampled signal takes the period of the impulse train signal. So the process of sampling can be explained by the mathematical expressions. So the sampled signal y of t is equal to x of t into dou of t. The sampled signal y of t is equal to x of t into the impulse train dou of t. So the trigonometric Fourier series representation of x of dou of t is given by dou of t is equal to a naught plus summation n equal to 1 to infinity of an cos n omega st plus bn sin omega st and so on. Here there is a naught is given as a naught is equal to 1 by ts into integration minus t divided by 2 to plus t by 2 dou of t, that is nothing but 1 by ts. Similarly, the coefficient an is expanded as an is equal to 2 by ts which is equal to 2 by capital T, that is whole time period, and as bn is given as, and it is 0, so that it ends up. Now we are substituting the values of the coefficients in the equations 2. So that is dou of t is equal to 1 by ts plus summation n equal to 1 to infinity 2 divided by ts into cos n omega s plus t. So now we have the values for x of t and dou of t. From that we can write the equation 1 as y of t equal to x of t dot dou of t is equal to x of t plus 1 divided by ts plus summation n equal to 1 to infinity 2 by ts cos n omega s of t. So now the common factor 1 by 2s is taken off, so x of t plus 2 into summation of n equal to 1 to infinity cos n omega s of t into x of t. So again we are expanding the summation equation so that y of t equal to 1 by ts into x of t plus 2 cos omega s into x of t plus 2 cos 2 omega s of t x of t and so on. So now we can take the Fourier transform on both the sides. So we get the expression in terms of spectrum. To reconstruct x of t, you should recover the input signal spectrum x of omega from the sampled output y of omega, which is possible only if there is no overlapping between the cycles of y of omega. The possibilities of sampled frequencies spectrum are given in the following diagrams. The longest intervals 1 by fm is equal to in terms of second.